All right, welcome back. I hope we had a good long weekend. So because of the snow, there's been a change in the calendar. So what I did is made a new calendar and I put it on everybody's table. So can everybody make sure you grab one of these little pieces of paper? It's on your table now. The old calendar, I just copied the 4 lines that are relevant. The old calendar is at the top. It has been replaced by the new stuff at the bottom. So we lost Thursday because of snow, crossed it off. Today is Tuesday the 18th. The homework that was due last class is due now. I'll continue to check it in a little bit. We're going to cover sections 1.7 and 1.8, which means that we are shortchanging a little bit section 1.6. Now, we had done all the stuff that we were going to do with my demonstration up here. You were going to continue to work in groups. I'm going to ask you to work on that blue packet on your own if you have time. We're going to cut the rest of that. So probably you didn't finish the blue packet work in class the other day. Maybe you can do it at home. We're going to move on and do a full 2 sections today, but I think it's these 2 sections are okay, smushing together just a little bit. Normally we do a section and a half. So today we're going to move a little bit and do 2. Homework due next time will be 1.6 and 1.7, but I don't want to assign 2 homework assignments with only 2 days in between. So if you cannot get 1.7 done by Thursday, I will take it for full credit next Tuesday. But I am going to insist that you do 2 assignments for next Tuesday. But you'll have 5 days between Thursday and Tuesday in which to do that. So I'm hoping it's not unreasonable. And then we'll be back on schedule for our review day a week from today, and then our exam. Now that review day happens right before the exam. That was what was scheduled. So the first part of the class will review just like we did for the quiz, and then the second part of the class you'll take the test. Any questions on the new calendar? Okay, then let's go back to blue page 72 for just a couple of quick announcements. So first of all, exam 1 is coming up soon, and there are a lot of resources for exam 1, including the yellow QEF packet with a practice exam inside of it. It's not too early to start studying for that exam. It's 1 week from today. And don't forget about peer tutoring as a possibility. Okay, today we're going to be using calculators. It'll be one of the few times that we're using calculators, and I just want to point out, I have some for you to borrow if you don't have one, but I want to point out that cell phones are not allowed on the tests for obvious reasons. So if you have only a cell phone calculator on you, I'm going to lend you one just so you can start to get a little bit comfortable with the kind that I'm going to lend you on the day of the test, okay? There are some geometry formulas that are going to be included on future quizzes and exams, but the formulas I give you are only for shapes with curved edges. For example, a sphere or a cone. You guys know what I'm talking about with a curved edge. But a formula I'm not going to give you is one that a couple of people had a little trouble with on the homework in the green packet. It was for a shoebox type shape and finding the volume of that. So length times width times height is the volume of a shoebox. So if you were able to do that homework question, then that's great. I will give you formulas for the curvy shaped objects. Okay, and then one last announcement. You're welcome to take the quiz, the exam that's coming up with any section. So if the date that we're scheduled for, which is right here a week from today, if that is not a good day for you, then take it with another class. You could take it 2 hours later than our class if you want to. Or you could take it on a Monday, Wednesday, or Friday if you see when the exam is offered for the other classes. Okay, so all that behind us, let's move on to page 73, and we'll go to the objective up here. Can we go to Jen? The objective, please. Okay, so last class we solved one-step equations, and today we're going to do the same thing, but there'll be word problems that the one-step equations come from. So you'll define variables and do all that stuff. But there is one, and that's kind of old, but there is one new technique that we're going to use, and it's to solve stuff like this in number 1. Can we get Matt? You seem brave. Can you read that equation for us in number 1? Okay, so that's the goal, is to solve that equation. Now, it's pretty clear that that equation is a whole lot different from the equations that we've been solving recently, right? Like we're solving equations like this. They will get more complicated soon enough, but this equation I'm giving you is a far cry from the ones that we saw the other day. So there's a different technique. Instead of actually going through all of the algebra to solve this, which some of you I trust would be able to do, but we're not there as a class at this moment. But instead of going through all that algebra, we're going to use a graph. And so this is the new technique. So take a look at this graph that's given. It's this diagonal line. What are the two variables in this graph? P and B, right? We're going to see them axes labeled. And then the equation of that graph is given right up here at the top. It's P equals all of that gobbledygook. Now that gobbledygook should look, well, maybe a little bit daunting, but it should look familiar. And so I'm just going to highlight that all of this is exactly the same as all of this. And that's not a coincidence. So what we're really saying is solve this equation, all this gobbledygook equals 60. But what's a name for all that gobbledygook according to the graph here? What letter did we use for all that gobbledygook? It's P. So what we're really saying is I want you to solve the equation P equals 60, right? Just giving it another name. Okay, so how are we going to do that? Well, let's go to the graph. Which axis is the P-axis? It's the vertical one. It's like the Y-axis. So you go to the place where P equals 60 is right there. And then we're going to draw an arrow. The goal is to figure out where that diagonal line is by either going left or right from this 60. Well, there's nothing to the left, so I'm just going to draw this arrow to the right until I magically hit that diagonal line. And from there, where do I go to solve the original equation? I'm going to go straight down, and we land someplace down here on what's normally the x-axis, but in this problem it's b. And we get some number down there. And whatever number we find right there is the answer to the original crazy equation that Matt read us. And if you look back at the original crazy equation, what's the variable? In the equation that Matt read us, it's b. P does not exist at all in that equation, right? The answer had better be, you can even start filling in the answer. The answer is going to be b equals some number. I don't know what it is, but it's definitely not p. But we're right here on the b-axis, and if we can figure out what that number is, then we win. So what is that number? 1, 2, 3, 4, 5 spaces into 20. Each of them is 4, 36. That's good. So down here is 36, and b equals 36 is our answer. I'm just going to put a little line here to separate the top stuff from the answer. b equals 36. Now the fact is, the answer to that crazy complicated equation might not be exactly 36. Anytime you're using a graph, you're estimating. So we assume that that graph hit perfectly on that like hash mark down there. I know the hash mark is at 36, but do I know that my purple line is exactly there? I don't, but I wouldn't be surprised if the answer were 36.1 or 35.8, something like that. And this is fine. Questions on how to solve crazy complicated? That's right. So Geneva's found kind of a special case. What if instead of p equals 60, it was p equals 24? So 24 happens to be right there. We don't have to go left or right at all because that's on the diagonal line, and we would just go straight down and get b equals 0. Yes? Yeah, there's a little bit of latitude that I have in terms of the right answer because we're estimating from a graph. One thing I definitely want to see from everybody are these purple lines here. So show me that you found the 60 in the right spot, because it's possible to find the 60 on the other axis, right? And then go up to here, and then go over to here and get 84. And it's, I mean, I don't know what the answer is. It's a crazy equation. So one way to get this wrong is to start from the wrong axis. So I'm going to ask you, instead of just going, see, like if you just give me these kinds of lines here and here, then I can't tell which axis you started from. What did I draw that makes it really clear which way we started from is the arrows. So I'm going to ask you guys to draw arrows for me so that I can tell where you started from. So include some arrows on the quizzes and tests, and include some arrows when you do these problems on the next page. So give it a shot, and we'll come back together about halfway through class. So we're jumping to page 83, which is the next section. As I said, we're kind of moving a little bit quicker than normal today to try to make up for that snow day that we missed. All of those pages that you just turned involve lots of word problems that I know you hate, but you should do, right? So lots of practice with those word problems. And I've been flashing up here today the answer key, like this kind of thing. Here was the sales price thing with the 0.8. So again, this PDF lives on our Moodle site. Every day it's released a couple of hours after class. So always you can check the answers to the blue stuff right here on Moodle. Okay, page 83. Back up here to the top. All right, so we'll go to the objective. Danny, can you read the objective, please? Okay, so like I said, this is one of the rare days where we're going to use calculators together in this class. But in your groups, I would like you to try these problems without a calculator first, and then we'll come back together in just a minute. Come on back together. All right, so for this first one here, there were a couple of answers that I saw. Some people just did 10 minus 3 is 7, plus 5 is 12. Some other people said, wait a minute, I know this thing called Pemdas from before, and it says that addition is first before subtraction. So if I do the addition first, I get 3 plus 5 is 8. 10 minus the 8 is 2. One of these is right, and the other one is flat wrong, and will forever be wrong. So we got to make sure we don't do the wrong one. So this whole Pemdas thing, PEMDAS, gives us a way to decide what to do first when we see multiple operations like addition and subtraction or multiplication in one expression here. This tells you what to do first. What does the P stand for? Parentheses. So if you see parentheses, you got to do whatever's in there before you do anything that's outside. After you finish all the parentheses, you move on to the E, exponents. So any exponents come next. After that, M is multiplication, D is division, A, addition, S, subtraction. And it seems to be saying that multiplication trumps division and addition trumps subtraction. It doesn't say that. So we're going to cross that off. And we're going to write it instead this way. And putting the M and the D aligned with each other vertically is our way of saying multiplication and division are equal in terms of priority. Equal. So do them left to right. Whichever one comes first, just like you read it, you do it first. So it's just like reading the English alphabet. And the same thing for A and S. Addition and subtraction are equal. Do them first. Okay, given that, what do we do first in B? Division or multiplication? Division. How come? Because it comes first and they are equal, right? Okay, so 24 divided 6 is 4 times 2, 8. Okay, here I have addition and multiplication. This is kind of a weird thing that we have to do when we're doing these calculations, because when you read the English language, you just read left to right, right? You don't have to absorb the whole thing and then decide what to do. We just read this left to right. And so it's tempting but wrong to do 10 plus 2, even though that's the first thing we read. We have to take a step back. Don't look at it from this kind of zoomed in view, but take a step back. Ask yourself, what are the operations? Oh, it's addition and multiplication. And when I have addition and multiplication, oh, I got to do multiplication first, regardless of the way I read the English language. So that multiplication goes first, and this is really saying 10 plus 6, which is 16. And then, again, don't look zoomed in, but look far away. What are the two operations in D? Subtraction and division. Which one gets the higher priority? Division. So we got to do the division first, which means I'm copying down the 14 minus until I do the division. 12 divided 2 is 6, and that one's 8. Okay, next one is down here, part A. It's another group thing, and then we will discuss. I would like you to calculate this thing on your calculator in one step. Now, before we use the calculator, let's just get the right answer without, because it turns out it's easier to do this without a calculator. What's the right answer to this one without a calculator? It's 5, right? You do 8 and 2 is 10. 10 divided by 2 is 5. So type this into your calculator, but you only get to hit the equal sign or the enter button one time. And if you just type it in as it sits, you might not get the right answer of 5. So talk to your neighbors and then we'll come back together. All right, let's take a look here. If you just type this thing into the calculator as we read it, 8 plus 2 divided by, sorry, is that right? Yeah, 8 plus 2 divided by 2. What do we get? 9, which is not the right answer. What is the calculator doing? We typed it in just as it sits. Why is the calculator saying 9 for this? It knows the order of operations. Calculator smart. Well, at least it knows the order of operations. And it says, oh, addition and division. I don't get to look at it close up. I got to take a step back and then say, okay, division has the priority. So what is it doing? It's doing 2 divided by 2. 8 plus 1, which is 9, which is not the right answer, but it's the right answer for what we typed in, which means we have to go out of our way to do something extra to tell the calculator, hey, there's a complicated numerator up here. That long division line, we can look at that and we can see that the 8 and the 2 are all upstairs, but the calculator can't see it. And so the way that we have to type this thing in, divided by 2, is to insert additional parentheses, tell the calculator that that 8 and 2 are all upstairs. And if you type it this way, you will get the right answer of 5. Now somebody asked, is it always just put parentheses around the numerator? The answer is no, actually. What you should do is put parentheses around both numerator and denominator. Turns out we don't need them around the bottom because the bottom is just a solitary number. But the safest thing to do, if you see a division problem and you're doing something on your calculator, is put parentheses around the entire numerator and the entire denominator. You'll get it right every time. All right, so moving on. This extra set of parentheses that we just put in here, this 8 plus 2, is something that we're going to call an implied set of parentheses. It's not really there. It's not necessary when we look at this thing, 8 plus 2 all over 2, but it's implied. And so the question is, how many implied parentheses do you have in these problems down here? So for example, in part A, what do you need to put parentheses around? The 2 plus 1. And you could put them around the 6, but they aren't necessary because the 6 is just a solitary number. So that's one pair of implied parentheses. With your neighbors, can you put in and then count the implied parentheses for the rest of part A? So let's come back together. Let's come back together. So I've written just a couple of things up here on the board. If you see a square root symbol, you need to get these extra parentheses in here. This is just something that we need to add to our list of things to know. And then Julia said it really well. She said, if you have a fraction line or a square root symbol, hug that stuff with parentheses. And it's just the two kinds of things that we're asking you to put parentheses around now. Fraction line and a square root symbol. So one set of parentheses for that guy right there. For the second one, we actually need both. Here's the reason. The reason is that you have a division and you also have an addition. And we need to go out of our way. What's the normal order of operations when you have division and addition? Which one comes first? Is division, but not in this problem because the entire addition is up above the division line. So whenever we're going to try to go against the natural order of operations, that's when we need to bring in these implied parentheses. Right? It's not about whether it's on top or on the bottom. It's about, are you going against the natural order of operations, that PEMDAS thing. So we need parentheses around both. In this last one, I've actually made a mistake. So I put parentheses around the numerator because that subtraction needs to come first, even though it doesn't normally. And then I saw a radical, so I put parentheses there. I'm missing one more set. Ending at the 5, where does it start? It's the entire thing right on the outside. This is a big division problem. And if I don't put parentheses there, then I've lost the fact that I need this addition to happen before the division happens, right? This is a division, this is an addition. I'm going against the natural order of operations, so parentheses around the entire denominator. So that one's got 3. 3 for this one, 2 for this one. Okay. The last example that we're going to do together is on the next page. We're going to try to calculate this without a calculator. I'm going to write lots of details, and then I'm going to show you the real shorthand way if you're not a real detail person. But Pemdas, what comes first? Parentheses, which means I'm going to copy the 2, I'm going to copy the 3, and I'm going to put these parentheses here. And I'm going to say whatever's in there gets priority, so that's where I focus my attention first. And you'll see when I write all these steps here, there's a lot of copying, a lot of waiting around. And whenever something is waiting, you copy. So in the parentheses, it's like this whole new Pemdas thing. I see addition and multiplication. What comes first there is the multiplication, which means I'm going to copy, put this in purple, the 10 and the plus because the multiplication gets priority. So lots of copying, except for the one thing that you actually get to do in this step, which is 2 times 15, and that's a 30. And now I'm ready to finish what's in the parentheses because there's only one thing to do there, and that's the addition. So this says 2 plus 3 times 40. So lots of copying. And then I see addition and multiplication. What goes first? Multiplication. So we're copying this 2 plus, and then we do the multiplication. 120. And then finally, addition gets to go last, 122. So that's if you like seeing all the details. I don't need you to put all the details. I need you to get 122. So if you don't want to put all the details and you just want to write a shorthand kind of thing, here's what you can do. You can look at this problem and you could say, okay, first thing I need is parentheses. Inside of there, it's multiplication. So cross off the 2 and the 15 and make it a 30. Right, that's the first step. And the next step is the 10 plus 30. I'm going to change colors here. Cross off 10 plus 30 and put 40. And then the 3 times 40 goes next. And that's a 120. And then 2 plus 120 is 122. That is not for the weak of heart. I mean, like this is, right? This is like you got to really know what you're doing to be able to cross off, keep track of all that. It takes a little bit longer to write this out, but I think it's probably more accurate for most of us to write out all the details. Either way is fine. I just want you to get to 122 without a calculator. Okay, down here is the whole Pemdas thing that we discussed. You can check it out later, as well as this paragraph on implied parentheses. You're moving on to the next page. Most of it is without a calculator, but some of it will ask you to use a calculator. Let's see how far we can get.